Hello guys, I hope everybody is able to hear me out. Okay, perfect. So let's start today's session. First of all, I hope everybody is doing fine, everybody is doing amazing, and you're learning too much from this session. Today is the day 6th, and today we'll be focusing on covering up this agenda. So, this is the agenda of today's session. Okay, this entire thing is the agenda of today's session, and yes, please make sure that you again have your pen and paper so that we will be able to discuss efficiently. Okay, so understand, till now we have discussed about a lot of supervised machine learning algorithms, and in those specific algorithms we have already discussed about different algorithms like linear, logistic. Then we discussed about KNN, okay, K nearest neighbor. We discussed about decision tree, ADA boost, XGBoost. I told you to basically check it from my one of my YouTube videos, because again I'm trying to cover it within 1.5 hours. So whatever is possible, I'll definitely try to cover it up. Okay. SVM, SVR, I've already uploaded in one of my video there, because I don't know whether we'll be able to cover everything or not. But tomorrow's whatever is missed, I'll try to cover those things also. Okay. So let's start. The first algorithm that we are probably going to discuss today is something called as K-means clustering. K-means clustering, and this is a kind of unsupervised machine learning. Okay. Now always remember, unsupervised machine learning basically means that the one and the most important thing is that in unsupervised machine learning, in unsupervised ML, you don't have any specific output. Okay, so you don't have any specific output. So suppose you have feature 1 and feature 2, and suppose you have datas, different data, and based on this data, what we do, we basically try to create clusters. This clusters basically says what are the similar kind of data. Okay, similar kind of data. So this is what we basically do from clustering, and there are various techniques like K-means, it is hierarchical clustering and all. So first of all, we'll try to understand about K-means and how does it specifically work. It's simple. Suppose you have a data points like this. Let's say that you have a data points. Suppose you have some data points like this. Okay, let's say that this is your F1 feature, F2 feature, and based on this in two-dimensional, probably I will be plotting this points, and suppose this is my another points. So our main purpose is basically to cluster together in different groups. Okay, so this will be my one group, and probably the other group will be this group, right? So two groups, because obviously you can see from this clusters here you have two similar kind of data which is basically grouped together, right? This is my cluster 1 and this is my cluster 2. Okay, let me talk about this and why specifically it will be very much useful, and then we'll try to understand about math intuition also. Now always understand guys, where does clustering gets used. Okay, in most of the ensemble techniques, I told you about custom ensemble technique, right? So custom ensemble techniques, in custom ensemble techniques, whenever we are probably creating a model, first of all on our data set, what we do is that we create clusters. So suppose this is my data set. During my model creation, the first algorithm we will probably apply will be clustering algorithm, and after that it is obviously good that we can apply regression or classification problem. Suppose in this clustering I have two or three groups. Let's say that I have two or three groups over here. For each group we can apply a separate supervised machine learning algorithm if we know the specific output that we really want to take ahead. Okay, I'll talk about this and give you some of the examples as I go ahead. Now let's go ahead and focus more on understanding how does k-means clustering algorithm work. Okay, so let's go over here. The word k-means has this k value. Okay, this k are nothing but this k basically means centroids. Okay, k basically means centroids. So suppose if I have a data set which looks like this, let's say that this is my data set. Now over here, just by seeing the data set, what are the possible groups you think? Definitely you will be saying k is equal to 2. So when you say k is equal to 2, that basically means you will be able to get two groups like this, and each and every group will be having a centroid point. Here also there will be a centroid point. Okay, so this centroid will determine, basically this is a separate group over here, this is a separate group over here. Okay, so over here you can definitely say that fine, this is two groups, but how do we come to a conclusion that there is only two groups? Okay, we cannot just directly say that okay, we will try to just by seeing the data, because your data will be having a high dimension data, right now I'm just showing you two dimension data, but for a high dimension data definitely you will not be able to see the data points how it is plotted. So how do you come to a conclusion that only two groups are there? So for this there is some steps that we basically perform in k-means. Okay, the first step, what is the first step? Let's write down the first step. The first step is that we try with different k values. Okay, and which is the suitable k value? K is nothing but centroids. Okay, it is nothing but centroids. We try with different centroids. Okay, in this particular case, let's say that I have this particular data point and I actually start with k is equal to 1 or 2 or 3, anyone you want. Let's say that I'm going to start with k is equal to 2. How to come up with this k is equal to 2 as a perfect value, that I'll talk about it. We need to know there is a concept which is called as within cluster sum of square. So when we try different k values, let's say that for k is equal to 2, what will happen? The first step, we try k values. So let's say that we are considering k is equal to 2. The second step is that we initialize k number of centroids. Now in this particular case, I know my k value is 2. So we will be initializing randomly, let's say that k is equal to 2. So what we can actually do, let's say that this is my one centroid. I'll put it in another color. So this will be my one centroid, and let's say that this is my another centroid. So I've initialized two centroids randomly in this space. Okay. Now after this particular centroid, what we have to do is that after initializing this centroid, what we have to do is that we have to basically find out which points are near to this centroid and which points are near to this centroid. Now in order to find out, it is a very easy step. We can basically use Euclidean distance, okay, to find out the distance between the points. In an easy way, if I really want to show you that like how many points I want to in an easy way, what I can do, I can basically draw a straight line over here. Let's say that I'm drawing a straight line over here in another color. Okay, I can draw a straight line, and I can also draw one parallel line like this. So this basically indicates that whichever points you see over here, suppose if I draw a straight line in between all these points, you will be able to see that, or let's say that I'm drawing one more parallel line which is intersecting together. So from this you can definitely find out, let's say that these are all my points that are nearer to this green point. Okay, so what I am actually going to do in this particular case, all these points that you are seeing near the green, it will become green color. So that basically means this is basically nearer to this centroid. Okay, and whichever points are nearer to this particular point, that will become red point. So that basically means this belongs to this group. Okay, this belongs to this group. Okay, so I hope everybody is clear till here. Then what will happen is that this summation of all the values, then we initialize the k number of centroids, that is done. Then we try to calculate a distance. We try to find out which all points is nearer to the centroid. Let's say that this is my one centroid, this is my another centroid. And we have seen that, okay, these all points belong to this centroid. It is near to this particular centroid. So this is becoming red. Okay. So this is based on the shortest distance. And here it is becoming green. Okay. Now the next step, let's see what is the next step after this. So I am going to remove this thing. Okay. Now the next step will be that the entire points that is in red color, okay, all the average will be taken. So here again the average will be taken. Now third step, here I am going to write, here we are going to compute the average. The reason we compute the average is that because we need to update the centroid. So compute the average to update centroid. To update centroids. Okay. So here you will be able to see that what I am actually doing. As soon as we compute the average, this centroid is going to move to some other location. So what location it will move? It will obviously become somewhere in center. So here now I am going to rub this, and now my new centroid will be this point where I am actually going to draw like this. Let's say this is my new centroid now. Similarly, this thing will happen with respect to the green color. Okay. So with respect to the green color also it will happen, and this green will also get updated. So I'm going to rub this, and this will be my new green point which will get updated over here. Okay. Then again what will happen? Again the distance will be calculated, and again a perpendicular line will be calculated. Here you can see that now all the points are towards there. Okay. Again the centroid, based on this particular distance, again it will be calculated, and here you can see that all the points are in its own location. So here now no update will actually happen. Let's say that there was one point which was red color over here, then this would have become green color. Okay. But since the updation has happened perfectly, we are not going to update it, and we are not going to update the centroid, right? So now you can understand that yes, now we have actually got the perfect centroid, and now this will be considered as one group, and this will be basically considered as the another group. Sorry, this will be considered as my another group. Okay. It will not intersect, but by default here intersection is happening. Harsha, please check your internet if the screen is blurry. Okay. Because of your internet, it is taking in different pixels. Okay. So I hope everybody has understood the steps that you have actually followed in initializing the centroids, in updating the centroids, and in updating the points. Is it clear, everybody, with respect to K-means? Yes, everybody? Everybody, is it clear? Everybody, is it clear? So what we are trying to do in this K-means clustering? Yes? Yeah, everybody? Perfect. Okay. Now let's discuss about one point. How do we decide this K value? Okay, how do we decide this K value? So for deciding the K value, there is a concept which is called as elbow method. Okay. So here I'm going to basically define my elbow method. Now elbow method says something very much important, because this will actually help us to find out what is the optimized K value, whether the K value should be 2, whether the K value is going to be 3, whether the K value is going to become 4. Okay. And always understand, suppose this is my data set. Initially, let's say that I have my data points like this. We cannot go ahead and directly say that, okay, K is equal to 2 is going to work. So obviously we are going to go with iteration. For I is equal to probably 1 to 10. I'm going to move towards iteration from 1 to 10. Let's say. So for every iteration, we will construct a graph with respect to K value and with respect to something called as WCSS. Now what is this WCSS? WCSS basically means within cluster sum of square. Okay, this is the meaning of WCSS, within cluster sum of square. Okay. Now let's say that initially we start with one centroid. So one centroid, let's say it is initialized here. Okay. one centroid is basically initialized here. If we go and compute the distance between each and every points to the centroid, and if we try to find out the distance, will the distance value be greater or it will be smaller? Tell me, will the value be smaller or greater? 1, 2, 3, 4, 5, 6. Will it be smaller or greater? Tell me, if we try to calculate this distance from this centroid to every point, this is what is within cluster sum of square, right? Tell me whether it will be greater or whether it will be smaller. Whether it will be greater or whether it will be smaller. It will always be very, very much greater. So let's say that my first point has come somewhere here. Okay. It is going to be obviously greater. Okay. Let's say that my first point is coming over here. Fine. So within k is equal to 1, initially we took and we found out the distance of WCSS, and it is a very huge value. Okay. Because we are going to compute the distance between each and every point to the centroid. Now the next thing that I'm actually going to do is that now we'll go with next value, that is k is equal to 2. Now in k is equal to 2, I will initialize 2 points. Okay, I will initialize 2 points, and then probably I will do the entire process which I have written on the top. Now tell me, whichever points is nearer to this green point, if we compute the distance, and whichever points is nearer to the red point, if we compute the distance like this, now this summation of the distance will be lesser than the previous WCSS or not? Obviously, it is going to be lesser than the previous WCSS. So what I'm actually going to do, probably with k is equal to 2, your value may come somewhere here. Then with k is equal to 3, your value may come somewhere here. Then k is equal to 4 will come here to 5, 6, like this it will go. Okay. So here, if I probably join this line, you'll be able to see that there will be an abrupt changes in the WCSS value. Okay. In the WCSS value, there will be an abrupt changes, and this is basically called as elbow curve. Now, why we say it as elbow curve? Because it is in the shape of elbow. Okay. And here at one specific point, there will be an abrupt change and then it will be straight. So that is the reason why we basically say this as elbow. Okay. So this is a very important thing. See, in finding the k value, we use elbow method. But for validating purpose, how do we validate that this model is performing well? We use Silhouette score, that I'll show you just in some time. But understand that in k-means clustering, we need to update the centroids, and based on that we calculate the distance, and as the k value keep on increasing, you will be able to see that the distance will become normal, or the WCSS value will become normal. And then we really need to find out which is the feasible k value where the abrupt change, see over here, suppose abrupt change is there and then it is normal, then I will probably take this as my k value. I hope everybody is able to understand. Okay. So obviously the model complexity will be high because we are going to check with respect to different k values and WCSS values. And this basically means that the value that we will probably get, first of all, we need to construct this elbow curve, then see the changes where it is basically happening. We'll need to find out the abrupt change. And once we get the abrupt change, we basically say that this may be the k value. So k is equal to 4. As an example, I'm telling you. Okay. So unless and until, if you really want to find the cluster, it is very much simple. We take a k value, we initialize k number of centroids, we compute the average to update the centroids. Then again, we try to find out the distance, try to see that whether any points has changed, and continue that process unless and until we get separate groups. Okay. So this is the entire funda of k-means clustering. Okay. So finally, you'll be able to see that with respect to the k value, will we be able to get that many number of groups. If my k value is 4, that basically means I will be probably getting 4 different groups like this. 1, 2, right? 3, like this, and 4. I will be getting 4 groups like this with k is equal to 4. That basically means k is equal to 4 clusters, and every group will be having its own centroids. Okay, every group will be having it with its own centroids. Okay, centroids are very much important. Okay. Yes, I'll try to show you in the coding also, guys. Don't worry. Now, let's go towards the second algorithm. The second algorithm that we will be probably discussing is called as hierarchical clustering. Now, hierarchical clustering is very much simple, guys. All you have to do is that, let's say this is your data points. This is your data points. Okay. Let's say this is your data points. Let's say this is your data points. And this is my P1, let's say P2. Okay. Now, hierarchical clustering says that we will go step by step. The first thing is that we will try to find out the most nearest value. Let's say this is my x and y. Let's say these are my points, like this is my P1 point, this is my P2 point, this is my P3 point, this is my P4 point, P5 point, P6 point, P7 point. Okay, so these are my points that I have actually named over here. Okay, now let's say that this is maybe the nearest point to each other. So what it will do, it will combine this together into one cluster. It will start combining into one cluster. So let's say that this we have computed the distance, so it will create one cluster. Okay, now what will happen on the right hand side, there will be another notation which you may be using in connecting all the points one. So suppose this is my P1, this is my P2, this is my P3, P4, P5 and P6. Okay, let's say that I have this many points, and probably I will also try to make P7. So these are my points P7. Okay, now you know that the nearest point that we are having, okay, this will probably be distance 1 2 3. This is distance. Okay, 4 5 6, like this we have lot of distance. Okay, so hierarchical clustering will first of all find out the nearest point and try to compute the distance between them and just try to combine them together into one. What do? We basically combine them into one group. Okay, so P1 and P2 has been combined. Let's say then it will go and find out the other nearest point. So let's say P6 and P7 are near, so they are also going to combine into one group. Okay, so once they combine into one group, then we have P6 and P7, which will be obviously greater than the previous distance, and we may get this kind of computation, and another combination or cluster will get formed over here. Then you have seen that, okay, P3 and P5 are nearer to each other, so we are going to combine this. So I am going to basically combine P3 and P5. Okay, and let's say that this distance is greater than the previous one, because we are basically going to start with the shortest distance and then we are going to capture the longest distance, right? Now this is done. Now you can see that the next point that is near, right, to this particular group is P4. So we are going to combine this together into one group. Okay, so once we combine this into one group, this P4 will get connected like this. Let's say it is getting connected like this. Okay, P4 has got connected. Then what is the nearest point, whether it is P6 P7 group or P1 P2? Obviously here you can see that P1 P2 is there, so I am probably going to combine this group together. Okay, that basically means P1 P2. Let's say I am just going to combine this group together. Again, circle is coming, so I will make a dot. Let's say I'm going to combine this group together because these are my nearest groups. So what will happen? P1 and P2 will get combined to P5. Sorry, P4, P5, this one. So I will be getting another line like this. Okay. And then finally you will be seeing that P6, P7 is the nearest group to this. So this will totally get combined and it may look something like this. So this will become a total group like this. So all the groups are combined. So finally you'll be able to see that there will be one more line which will get combined like this. This is basically called as dendrogram. Dendrogram, okay, which is like bottom root to top. Okay. Now the question rises is that how do you find that how many groups should be here? Okay. How do you find out that how many groups should be here? The funda is very much clear, guys, in this is that you need to find the longest vertical line. You need to find out the longest vertical line that has no horizontal line passed through it. No horizontal line passed through it. This is very much important. That has no horizontal line pass through it. Now, what this is basically meaning is that I will try to find out the longest line, longest vertical line in such a way that none of the horizontal line passes through it. What is horizontal line? Suppose if I consider this vertical line over here, if you see that if I extend this green line, it is passing through this. If I extend this line, it is passing through this, right? If I'm extending this line, it is passing through this, right? So out of this, the longest line that may be passing uh, in such a way that no horizontal line probably is this line that I can actually see. Okay. So what you do over here is that you basically just create a straight line over this, and then you try to find out that how many clusters it will be there by understanding that how many lines it is passing through. If it is passing through this one line, two line, three line, four line, that basically means your clusters will be 4 clusters. This is how we basically do the calculation in hierarchical clustering. Again, here it may not be the perfect line. I've just drawn with some assumptions, but if you are trying to do this, probably you have to do in this specific way. Okay, I've already uploaded a lot of practical videos with respect to hierarchical clustering and all. Okay, everybody clear? Yes, everybody clear with this? How does hierarchical clustering actually work and K-means clustering? Now tell me, maximum effort or maximum time is taken by K-means or hierarchical clustering? This is a question for you. This is a question for you. Yes, guys, number of clusters may be 3, but here I'm just showing you that how many lines it may be passed by. Okay. Now tell me, how do you basically determine whether maximum time will be taken by K-means or hierarchical clustering? This is the interview question. Maximum time. The maximum time that will be taken is by hierarchical clustering. Why? Because let's say that I have many data points. Okay. At that point of time, hierarchical clustering will keep on constructing this kind of dendrograms, and it will be taking many time. Lot time, right? So hierarchical clustering will take more time. Okay. Maximum time that it is going to basically take. Okay. So it is very much important that you understand which is basically taking more time. So if your data set is small, you may go ahead with hierarchical clustering. If your data set is large, go with K-means clustering. Go with K-means clustering. In short, both will take more time, but K-mean will perform better than hierarchical clustering. Okay. See guys, you will be forming this kind of dendrograms, right? And just imagine if you have 10 features and many data points, how you are going to do it? It will be a cumbersome process. Okay. You will not be even able to see this dendrogram properly. And manually, obviously, you cannot do it. Okay. So this was with respect to K-means clustering and hierarchical mean clustering. I hope everybody is understood. Now the next topic that we'll focus on is that how do we validate? See, how do we validate a classification problem? We use performance metrics like confusion matrix, accuracy, different true positive rate, precision, recall. But how do we validate clustering models? So for validating clustering models, we are going to use something called as Silhouette score. I'll show you what Silhouette score is. I'm going to just open the Wikipedia. So this is how a Silhouette score looks like. A very amazing topic. Okay. How do we validate whether my model basically has perfect 3 or 4 model? Perfect 3. Suppose if I find out my K value is 3, how do we find out? Okay. Now see, one more issue with K-means, which I forgot to tell you. Let's say that I have a data point which looks like this, And suppose I have some data points like this. I have some data points which looks like this. Okay. Let's say I have like this. Now in this, one issue will be that suppose I try to make a cluster over here. Obviously, you'll be saying my k value will be 2. Okay. In this particular case, suppose this is one cluster, this is my another cluster, right? And because of my wrong initialization of the points, okay, understand, because suppose if I initialize just randomly some centroids like this, then what may happen is that there is a possibility that we may also have 3 clusters like this kind of clusters. One cluster will be here, one cluster will be here, one cluster will be here. So this initialization of the centroids, one condition is that it should be very far. If we initialize our centroids very far, at that point of time we will be able to find the centroid exactly in the center, because it will keep on updating, it will keep on going ahead, right? But if we don't initialize that very far, then there will be a situation that probably if I wanted to get only, the real thing was to get only 2 centroids, I was probably getting 3 centroids, right? So this is a problem. So for this, there is an algorithm which is called as K-means plus plus. And what this K-means plus plus will do, which I will probably show in practical, this will make sure that all the centroids that are initialized, it is very far. Okay, all the centroids that is basically there, it is initialized very far. We'll see that in practical application where specifically those centroids are basically used. Now let me go ahead and let me show you with respect to silhouette clustering. Now, what is this silhouette clustering? I'm going to explain you in an amazing way. This is important. If someone says you, how do we, just a second, how do we validate cluster model? Then at that point of time, we basically use this silhouette. It will be used in, it will be used with respect to k-means. It can be used in hierarchical mean, right? If you want to validate, how do we validate? Okay, that is what we are basically going to see over here. Okay, now in k-means clustering, what are the most important things? Okay, the first and the most important thing is that we will try to find out a of I. Okay, we will try to find out a of I. Now what is this a of I? See, this a of I that you basically see, a of I is nothing but, see, 3 major steps happens in order to validate cluster model with the help of silhouette. First thing is that I will probably take one cluster, okay, there will be one point which will be my centroid, let's say, and then what I am going to do, I'm just going to, whatever points are there inside this cluster, I'm going to compute the distance between them. So I'm going to do the summation and I'm also going to do the average of all this distance. So here you can see that when I say distance of I comma j, I basically means this point, j basically means all these points. I is nothing but it is the centroid. So here is nothing but this is the centroid. Let's say that I am having this centroid. Okay. So I'm going to compute all the distance over here which is mentioned by this, and this value that you see that I am actually dividing by c of I minus 1. In short, I am actually trying to calculate the average distance. So this is the first point where I am actually computing the a of I. Okay. Now similarly, what I will do is that the next point will be that, suppose I have computed a of I, the next thing that we need to compute is something called as b of I. So next thing that we need to compute is b of I. Now what is b of I? B of I is nothing but we will try to take another centroid, like there will be definitely multiple centroids, there will be multiple clusters in a k-means problem statement. We will try to find out the nearest cluster. Okay, suppose let's say that this is the nearest cluster and in this I have all the variety of points. Then b of I basically says that I will try to compute the distance between each point and the other point in this centroid. Sorry, in this cluster. So this is my cluster 1, this is my cluster 2. So what I'm actually going to do is that here I'm going to compute the distance between this point to this point, then this point to this point, then this point to this point, this point to this point, this point to this point, this point to this point. Every point I'm actually going to compute the distance. Once this point is done, we will go ahead with the next point and we'll try to compute the distance. And once we get all this particular distance, what we are going to do? We are going to do the average of them. Average. Okay. Now tell me, if I try to find out the relationship between A of I and B of I, if my cluster model is good, will A of I will be greater than B of I, or will B of I will be greater than A of I if I have a good clustering model? Tell me. If I have a good clustering model, will A of I is greater than B of I, will be greater than B of I, or whether B of I will be greater than A of I? Out of this, if we have a really good model, tell me guys. Tell me guys, whether A of I will be greater than B of I, or whether B of I will be greater than A of I in a good model. Obviously, the distance between B of I will be greater than A of I in a good model. Okay. That basically means if I talk about silhouette clustering, the values will be between -1 to +1. The more the value is towards +1, that basically means the good the model is, the good the clustering model is. Okay. The more the value is towards -1, that basically means this condition is getting applied. Now, what does this condition basically say? That basically means that this distance is far than the cluster distance. This is what this information is getting portrayed. And this is the importance of silhouette clustering. Finally, when we apply the formula of silhouette clustering, you will be able to see that silhouette clustering is nothing but, let me rub this everything guys for you. Okay, let me just show you what is silhouette clustering. Silhouette clustering formula will be something like this. B of I, so here you have silhouette clustering. This is the formula. B of I minus A of I max of A of I comma B of I if C of I is greater than 1. Right? So by this, you will be getting the value between -1 to +1. And more the value is towards +1, the more good your model is. More the value is towards -1, more bad your model is. Because if it is towards -1, that basically means your A of I is obviously greater than B of I. Okay. So this is the outcome with respect to silhouette clustering. So everybody wants to do a practical session? Just let me know. I hope everybody understood till here. We'll also discuss about DBScan, don't worry. DBScan is pretty much amazing than KMeans and Hierarchical mean. I'll discuss about what is exactly DBScan and then we'll discuss about the practical problem and then we'll finish it off. So I hope you had an amazing way of learning things. If S is equal to 0, that basically means still your model needs to be basically the clustering needs to be improved. Okay. Okay. What is I over here? I is nothing but one data point. You can just read this, guys. Data point in I in the cluster C of I. Okay. So I hope everybody has understood this. Now let's go ahead and let's discuss about the next topic. We have obviously finished up silhouette clustering over here. Let's discuss about something called as DBScan. So for DBScan clustering, this is an amazing clustering algorithm. We'll try to understand how to actually do DB clustering, and probably you'll be able to understand a lot of things from this. Let me show you one diagram. I'm going to take this diagram, just a second. Yeah, practicals I'll come ahead. Don't worry. Please hit like so that we'll be able to understand much because I'll get the energy. When I get the energy, I will be able to explain properly. I'm just kidding, anyhow. If you don't like, also, it's okay. Okay. Now, in DBScan clustering, what are the important things? Okay. Shall I start, everyone? Okay. Shall I start, everybody? Okay. So, let's start with respect to DBScan clustering and let's understand some of the important points over here. The first point that you really need to remember is something called as core points. I'll also talk about when do you say core points or when do you say other points as such. So the first point that I will probably discuss about is something called as min points. The second point that I will probably discuss about is something called as core points. Okay. The third thing that I will probably discuss about is something called as border points. And the fourth point that I will definitely talk about is something called as noise point. Okay, guys. Now tell me, in 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 K-means clustering, if I have this kind of groups, don't you think with the help of two different clusters, I may combine this two like this? Yes. With the help of two different clusters, I may combine something like this, right? But understand over here, what problem is basically happening with the second clustering? This is actually an outliers. Let's say that let's say one thing very nicely I will put. Okay, let's say I have one point over here. I have one point over here. So if I do clustering, probably I will get one cluster here and I may get another cluster which is somewhere here. Okay. Now understand one thing. This point is definitely an outlier. Even though this is an outlier, with the help of K-means, what I'm actually doing, I'm actually grouping this into another group. So can we have a scenario wherein a kind of clustering algorithm is there where we can leave the outlier separately? And this outlier in this particular algorithm, and this is basically we will be using DBScan to relieve the outlier, and this point will be called as a noisy point. Noisy point, or I can also say it as an outlier. So this will be a noise point. Okay. So for this kind of algorithm where you want to skip the outliers, we can definitely use DBScan. That is density based spatial clustering of application with noise. A very amazing algorithm, and definitely I have tried using this a lot. Nowadays I don't use K-means or hierarchical means, instead I use this kind of algorithm. Okay. Now see this. What are the important things? Over here, first of all, you need to go ahead with min points. Min points. So first thing is that you need to have min points. This min points is a kind of hyperparameter. This basically says, what does hyperparameter says? And there is also a value which is called as epsilon, which I forgot. I will write it down over here. This is called as epsilon. Now what does epsilon mean? Epsilon basically means if I have a point like this, and if I take epsilon, this is nothing but the radius of that specific circle. Okay, radius of that specific circle. Okay, so epsilon is nothing but radius. Okay, over here in this specific thing. Now what does minimum points is equal to 4 mean? Let's say that I have have taken a point over here. Let's say that this is my point, and I have drawn a circle which looks like this. Okay, and let's say that this is my epsilon value. Okay, this is my epsilon value. If I say my min point is equal to 4, which is again a hyperparameter, that basically means I can, if I have at least 4 points over here, at least 4 points over here, okay, at least 4 points near to me, near to this particular circle based on this epsilon value, then what will happen is that this point, this red point, will actually become a core point, which is basically given over here. Okay, if it has at least that many number of min points inside or near to this particular, within this epsilon, okay, within this particular cluster. Suppose this is my cluster. With the help of epsilon I have actually created it. Okay, is there a particular unit of epsilon, or we simply take the unit of distance? No, epsilon value will also get selected through some way. Okay, I'll show you in the practical application, don't worry. Okay, now the next thing is that let's say I have another point over here. Let's say that I have another point over here, and this is my circle. With respect to epsilon I have created it. Let's say that here I have only one point. I have only one point inside this particular cluster. At that point, this point becomes something called as border point. Border point. Border point also we have discussed over here. Right? So border point is also there. Okay. So here I am saying that at least one. If it is only one, it is present. Okay. Then it will become a border point. If it has force, definitely this will become a core point. Core point, like how we have this red color. Okay. So, and there will be one more scenario. Suppose I have this one cluster. Let's say this is my epsilon. And suppose if I don't have any points near this, then this will definitely become my noise point. And this noise point will nothing be, but this will be a cluster. Okay. So here I have actually discussed about the noise point also. Right. So I hope everybody is able to understand the key terms. Now what is basically happening is that whenever we have a noise point, like in this particular scenario, we have a noise point and we don't find any points inside this, any core point or border point, if we don't find inside this, then it is going to just get neglected. It is just going to get neglected. That basically means this is basically treated as an outlier. Okay. I hope everybody is able to understand here. This point will be treated as an outlier, or it can also be treated as a noise point. And this will never be taken inside a group. Okay, it will never be taken inside a group. Suppose I have this set of points which you see basically over here, red core and all, and there is also a border point. By making multiple circles over here you can definitely say that how we are defining core points and the border points, and this can be combined into a single group. Okay, this can be combined into a single group, because how the connection is, now see this yellow line is basically created by this yellow point is basically created by one epsilon, and we have one core point over here. Remember, over here it should be at least one core point. Okay, not one point, but one core point at least. If it is having one core point, then it will become a border point. This will become a border point. That basically means, yes, this can be the part of this specific group. Okay, so understand these things. Don't worry guys, tomorrow XGBoost will get covered. We'll also cover SVM and SVR. Don't worry. Okay, focus on the session right now. So what we are doing, whenever there is a noise, we are going to neglect it. Wherever there is a border and core points, we are going to combine it. So I'll show you one more diagram, which is an amazing diagram, which will help you understand more in this. Just give me a second. I'm just going to keep that screenshot. Now I'm going to show you the difference between a K-means clustering and hierarchical mean clustering. Now see this, everybody. I hope everybody is able to see this group. See this. Don't worry, guys. SVM XGBoost, tomorrow I'll complete it. Now, the right hand side of diagram that you see is based on DBScan clustering. And the left hand side is basically your traditional clustering method. Let's say that this is K-means. Which one do you think is better? Over here you see this. These are all outliers, are not combined inside a group. But whichever are nearer as a core point and the broader point, separate groups are actually created. Right? So this is how amazing a DBScan clustering is. Right? A DBScan clustering is pretty much amazing. That is basically the outcome of this. Here in K-means clustering, you can see this all these points has also been taken as blue color as one group, because I'll be considering this as one group. But here we are able to determine this in amazing groups. So I'm saying you guys directly use DBScan without worrying about anything. Okay. So now let's focus on the practical part. I'm just going to give you a GitHub link. Everybody, please download the GitHub link. Download the code. So download the code, guys. I've given you the GitHub link. Quickly download and keep your file ready. I'm also going to download. I'm going to open my Anaconda prompt. Probably open my Jupyter notebook. We'll do one practical problem. I've given you the link, guys. Please open it. So this is what we are going to do today. Just let me know once you have downloaded it or not. And hit like. Let's make it at least 300. How to download? You don't know how to download? I've given you the GitHub link, no? Seriously, you don't know how to download? So this is the GitHub link. Go to the code, download the zip file, or fork this entire repository. Just download the zip file. And please open the file and keep it ready, and then we will try to explain. See this. This will be amazing. Here you will be able to see amazing things. How do you come to know that overfitting or underfitting is happening? You don't know the real value, right? So in clustering, there will not be any underfitting or overfitting. Everybody ready? Everybody ready? Just give me a confirmation. It's so amazing. Daily 5 to 6 messages I get where people are making successful career transition. Amazing. 5 to 6. Today I got around 10 messages, both in LinkedIn and the other platforms, WhatsApp. Many people. Many people are getting jobs in data science. They are part of amazing, right? So this is basically the motivation. Okay, now let's start. Everybody focus on the code over here now. So what all things we will be importing? First is that we'll try k-means clustering. We'll do silhouette scoring, and then probably we'll see the output. Okay, and And we'll do DBScan also. Let's say DBScan is also there. DBScan, I'll refer it to one video so that you can check it from there. Not a problem. Okay. So, what are the things we have basically imported? One is the K-means clustering, one is the Silhouette samples and Silhouette scores. These all are present in the sklearn, and it is present in the metrics. That basically means we use this specific parameter to validate clustering models. Okay. Now we'll try to execute this, and apart from that, matplotlib we are just trying to import, numpy we are trying to import and all. Okay. So here we are executing it perfectly. The next thing is that here the next step is that generating the sample data from make underscore blobs. First of all, we are just trying to generate some samples with some two features, and we are saying that okay, it should have 4 centroids or C centroids itself. With some features, I'm trying to generate some X and Y data randomly. Okay, and this particular data set will basically be used in performing clustering algorithms. Okay. Forget about range underscore n underscore clusters, because we need to try with different clusters and try to find out the Silhouette score. So right now I've just initialized with 2, 3, 4, 5, 6 values. Okay. So it is very simple. So if I go and probably see my X data, so my X data will look something like this. So this is my X data with 2 features, and this is my Y data with 1 feature, which is my output, which belongs to a specific class. Okay. So that you can actually do with the help of make underscore blobs. Okay. Now let's say how to apply K-means clustering algorithm. So as I said that I will be using WCSS. WCSS basically means within cluster sum of square. So I'm going to import K-means over here for I in range 1, 11. That basically means I'm going to use different K values or centroid values and try to see which is having the minimal WCSS value, and I'll try to draw that graph which I had actually shown you with respect to elbow method. So here I will basically be also using K-means, number of clusters will be I, and initialization technique I will be using K-means plus plus, so that the points, the centroids that are initialized, those points are very far. Okay. And then you have random state is equal to 0, then we do fit, and finally we do WCSS dot append K-means dot inertia. Okay. This dot inertia will give you the distance between the centroids and all the other points. Okay. And this is what I'm going to append in this WCSS value. And finally, I'll just plot it. Now here you can see that I'm just plotting it. Obviously, by seeing this graph looks like an elbow. Okay. This graph looks like an elbow. So the point that I'm actually going to consider over here, see which is the last abrupt change. So if I talk about the last abrupt change, here I have the specific value with respect to this. Okay, I have one specific value with respect to this. This is my abrupt change. From here, the changes are normal. So I'm going to basically select k is equal to 4. Now what I'm actually going to do with the help of Silhouette, I hope I'm sorry, with the help of Silhouette plus score, we are going to compare whether k is equal to 4 is valid or not. So that is what we are going to do. Okay, valid or not. So here we are going to do this. Okay. Now let's go ahead and let's try to see it, how we are going to do it. So here you can see n clusters is equal to 4, then I'm actually able to find out the prediction, and this is specifically my output. Okay, this is done. Now see this code. Okay, this code is a huge code. I have actually taken this code directly from the sklearn page of Silhouette. Okay, if you go and see this code is directly given over there. But I'm just going to talk about like what are the important things we need to see over here with respect to different clusters. See this clusters 2, 3, 4, 5, 6. I'm going to basically compare whether the k value should be 4 or not with the help of Silhouette scoring. Okay. So let's go over here, and here you can see that I'm applying this one. First, I will go with respect to for loop. For n underscore clusters in range underscore clusters, different cluster values are there. First, we'll start with 2. So here you can see initialize the cluster with n cluster value and a random generator seed of 10 for reproducibility. So n underscore clusters, first I took it as 2, and then I did fit predict on x. After I did fit predictor on x, I am using this score on x comma cluster label. Now what this is going to do, understand in Silhouette, what did we discuss? We discussed that, what did we discuss? It will try to find out all the clusters over here like this, and it will try to calculate the distance between them, which is the a of I. Then it will try to compute the b of I. Then finally it will try to compute the score. And if the value is between -1 to +1, the more the value is towards +1, the more better it is, right? So these all things we have already discussed, and that is what this specific function will do, and this will give my Silhouette average value over here. Okay, Silhouette value will be over here. Okay, this we have done, and then we can continuously do it for another things. You can actually find it over here, and this value that you see, this code that you see, is nothing so complex. Okay, this is just to display the data properly in the form of graphs. Okay, in the form of graphs. So again, I'm telling you, I did not write this code. I've directly taken it from the sklearn page of Silhouette. Okay, so just try to see this particular plotting diagrams and all that you can definitely figure out. But let's see, I will try to execute it and try to find out the output. Now see, for n underscore cluster is equal to 2, the average Silhouette score is 0.70. I told you the value will be between -1 to +1, and I am actually getting 0.704, which is very, very good. Okay, and then for n underscore cluster is equal to 3, 0.588. Then n underscore cluster is equal to 4, I'm getting 0.65, which is pretty much amazing. And then for n underscore cluster is equal to 5, the average score is 0.563, and n underscore cluster is equal to 6, you are saying 0.45. Here directly you can actually say that, fine, for n underscore cluster is equal to 2, I'm getting an amazing score of 0.704. Okay, obviously you're getting the highest value over this. So should we select n underscore cluster is equal to 2? Should we? Okay, we should not directly conclude from it, because here we need to also see that any feature value or any cluster value is also coming as negative value. That also we need to check. So here we will go down over here. You will see the first one. Over here with respect to the first one, you see that I'm getting the value from 0 to 1. It is not going to -0.1. So definitely 2 clusters was able to solve the problem. So I'll keep it like this with me. I definitely have a chance that this may perform well. I may have a chance that this k is equal to 2 may perform well. Okay, so I may have a chance. Let's see to the next one. To the next one over here, you can see that for one of the cluster, the value is negative. If the value is negative, that basically means the AI is obviously greater than B of I. So I'm not going to refer this because it is having some negative values. Even though my cluster looks better, but again, understand what is the problem with respect to this cluster is that if I take this cluster and probably compute the distance between this point to this point, and if I probably compute from this point to this point or this point to this point is obviously nearer to this, right? It is obviously nearer to this. So that is the reason why I'm getting a negative value over here. Okay, negative value over here. This is my output, my score. This point that you see dotted points, this is my score. 0.58, whatever it is, this is basically my score. Okay, so obviously this basically indicates that this point is nearer, the other cluster point is nearer to this, so I'm actually getting a negative value, right? So this you really need to understand. Okay, now similarly, if I go with respect to n underscore cluster is equal to 4, this looks good because here I don't have any negative value. And here you can see how coolly it has basically divided the points amazingly with the help of k is equal to 4, right? And similarly, if I go with 5, obviously you can see some negative values are here, some dotted line negative value are there. With respect to 6, you also have some negative values. So definitely I'll not go with 6. I may either go with 4 or I may either go with 2. Now, whenever you have this options, always take a bigger number. Instead of 2, take 4 because 4 is greater than 2 because it will be able to create a generalized model. So from this, I am actually going to take n is equal to 4, k is equal to 4. Now, should we compare with this with the elbow method? Here also I got 4, right? So both are actually matching. So this indicates that with the help of this clustering, this Silhouette score, we can definitely come to a conclusion and validate our clustering model in an amazing way. Okay, so I hope everybody is able to understand, right? I hope everybody is able to understand this specific thing. Just tell me. And this way you basically validate a model. And definitely you can try it out, you can understand this code. Definitely because I have also copied this code, I will probably go and see each and every parameter based on the matplotlib. But till here you have understood that here I am going to get the average value. Then for I in underscore clusters, whatever cluster this is matching, it is just mapping over there and it is basically giving. Okay, perfect. So this was the session, and yes, in today's session we efficiently covered many topics. We covered K-means, hierarchical clustering, silhouette score, DBScan clustering. In tomorrow's session, the topics that are probably pending is, first I'll start with SVM and SVR. Second, I will go ahead with XGBoost, and third, I will cover up PCA. Let's see whether I'll be able to complete this session. One amazing thing that I want to teach you guys, because many people ask me the definition of bias and variance. Definition of bias and variance. So should I explain this? Should I explain this, everyone? Just let me know. Should I explain this? It's okay. Who have not understood, please revise the session. Okay. So let's go ahead and let me do one thing. I will also do one good thing in this, is that yeah, we're going to understand about definition of bias and variance. Okay, let's understand. So guys, many people get confused when we talk about bias and variance, because let's say that I have a model for the training data set. For the training data set, it gives us somewhere around 90% accuracy. Let's say I'm getting a 90% accuracy. For the test data, I may probably getting somewhere around 70% accuracy. Now tell me which scenario is basically this. Most of the people will be saying that, okay, fine, it is overfitting. Now when I say overfitting, I basically mention overfitting by low bias and high variance, right? So many people get confused. Krish, tell me just the exact definition of bias and variance. Low bias, obviously you are saying that because the training is performed, like the model is performing well with the help of training data set. But with respect to the test data set, the model is not performing well. With respect to training data set, why do we always say bias? And with respect to test data set, why do we always say variance? Okay, so for this, you need to understand the definition of bias. So let me write down the definition of bias over here. So here, I can definitely write that bias, it is a phenomena, it is a phenomena that skews, that skews the result of an algorithm in favor, in favor in favor or against an idea, against an idea. I'll make you understand the definition, but understand what I have actually written over here. It is a phenomena that skews the result of an algorithm in favor or against an idea. Whenever I say this specific idea, this idea I will just talk about the training data set initially. Okay, training data set. Now, when we train a specific model, suppose if I have this specific model over here, and I'm training with this specific training data set. So this is my training data set. Training data set. Now, based on the definition, what does it basically say? It is a phenomenon that skews the result of an algorithm in favor or against an idea or this specific training data set. So, even though I'm training this particular model with this training data set, okay, it may be in favor of that or it may be against of that. That basically means it may perform well, it may not perform well. If it is not performing well, that basically means the accuracy is down, right? If the accuracy is better, at that point of time, what we'll say? See, if the accuracy is better, that time what we'll say, we'll come up with two terms from here. Obviously, you understand, okay, there are two scenarios of bias now here. If it is in favor, that basically means it is performing well with respect to the training data set. I will basically say that it has high bias. If it is not able to perform well with the training data set, then here I will say it as low bias. I hope everybody is able to understand in this specific thing, because many people has this kind of confusion. Okay. Now similarly, if I talk about variance, let's say about variance, because you need to understand the definition. A definition is very much important. Okay. If I just talk about the definition of variance, I'm just going to refer like this. The variance refers to the changes in the model when using different portion of the training or test data. Now let's understand this particular definition. Variance refers to the changes in the model when using different proportion of the training data or test data. We obviously know that whenever initially, if I have a model, understand from the definition, everything will make sense. I am basically training initially with the training data. Okay, because we divide our data set. See, our data set, whenever we are working with, we divide this into two parts. One is our train data and test data. Okay, because this is a test data is a part of that particular data set, right? And suppose in this particular training data, it gets trained and performs well. Here I'm actually talking about bias. But when we come with respect to the prediction of this specific model, at that point of time, I can use other training data. That basically means that training data may not be similar, or I can also use test data. Now in this test data, what we do some kind of predictions. These are my predictions. And in this prediction, again, I may get two scenario. Which is basically mentioned by variance. It refers to the changes in the model when using different portion of the training or test data. Refers to the changes basically means whether it is able to give a good prediction or wrong predictions. That's it. So in this particular scenario, if it gives a good prediction, I may definitely say it as low variance. That basically means the accuracy with respect to the test data is also very good. If I probably get a bad accuracy, at that time I basically say it as high variance. So if I talk about three scenarios over here, let's say this is my model 1 and this is my model 2 and this is my model 3. Now in this scenario, let's consider that my model 1 has the training accuracy of 90% and test accuracy of 75%. Similarly, I have here as my train accuracy of 60% and my test accuracy of 55%. Now, similarly, if I have my train accuracy of 90% and my test accuracy of 92%. Now tell me what things you will be getting. Here, obviously, you can directly say that fine, your training accuracy is better. Now you're talking about bias. So this basically indicates that this has low bias. And since your test accuracy is bad, because it is when compared to the train accuracy, it is less. So here you are basically going to say high variance. Understand with respect to the definition. Similarly over here, what you will say? High bias, high variance, because obviously it is not performing well. This is the another scenario. The last scenario is that this is the scenario that we want because it is low bias and low variance. Okay, many people have basically asked me the definition with respect to bias and variance, and here I've actually discussed, and this gives me a generalized model, and this is what is our aim when we are working as a data scientist. So I hope you have understood the basic difference between bias and variance, and I was able to give you a lot of examples, lot of understanding with respect to this. So I hope you have actually got this particular uh, understanding of this two terms which we specifically talk about: bias, high variance, low variance. Right? So this was it from my side, guys, uh, and I hope you have understood this. So I hope you have understood. Just give me a statement, something. So till when I can avail TechNeuron lifetime subscription, guys? Get it within March. After that, the price of the TechNeuron is going to increase to 20,000. Okay, and you'll not be getting for lifetime. Their time yearly, 3 years subscription plan will be there. Okay, so it is up to you. Later on, don't complain to me. Okay, I don't have anything in my hand for that. So this is my definition of bias. High bias, higher variance. Okay. So hit like, guys. I hope you like this session. How was this session? Can you give me the rating out of 10? Because I have put up my 100% energy because I was having a lot energy today. Okay. So I hope you liked it. Hit like. Make sure that you put this. Upcoming from tomorrow, I'll announce like probably deep learning. I'm taking a 4 days gap because I am traveling somewhere. And after that, probably I will announce deep learning, EDA. I'm also planning to make Django for web framework complete 7 days live series. Right. So yes, please do hit like, make it 500 likes at least. I know for the people, for not everyone, this may be useful, because I don't know. I still see the count of the people that are coming are very less, but it's okay. Whoever it is being helpful for them, it is very good. Okay. So thank you. In tomorrow's session, we'll discuss about the remaining algorithm that is left. Bye bye. Have a great day ahead. Keep on rocking. Keep on learning. Thank you, everyone. See you tomorrow. Okay, tomorrow is the 7th day and the last day.